Download this code from codegive.com, link in the description below. Connection broken when connection options socket timeout is set, a detailed tutorial. This tutorial dives deep into the connection broken errors you might encounter when using connection options with socket timeouts in your programming language or framework, primarily focusing on scenarios relevant to networking and client-server communication. We'll cover the underlying causes, potential solutions, and provide illustrative code examples. Understanding the problem, connection broken and socket timeouts. Connection broken, or connection reset, connection aborted, broken pipe, etc. Errors typically indicate that the established communication channel between two endpoints, example a client and a server, has been unexpectedly terminated. One endpoint stopped sending data, closed the connection abruptly, or encountered an error that caused the connection to drop. Socket timeouts, a mechanism for resilience. Socket timeouts are a fundamental mechanism for handling network failures gracefully. They allow your application to avoid hanging indefinitely when a connection becomes unresponsive. Connection options, or similar settings in your networking library, often let you configure timeouts for various aspects of a socket connection, including *connect timeout *, the maximum time allowed to establish a connection with the server. If a connection cannot be made within this time frame, the connection attempt fails with a timeout exception. *read timeout, so _timeo the maximum time the socket will wait for data to be received after a read operation is initiated. If no data arrives within this period, a timeout exception is raised. This is the most common timeout related to connection broken issues. *write timeout, so _tin timeo the maximum time the socket will wait for data to be sent. If the data cannot be sent within this time frame, example due to network congestion or the remote end not accepting data, a timeout exception occurs. Why connection broken with socket timeouts? The interaction between socket timeouts and connection failures can be tricky. Here's why setting a read timeout can lead to apparent connection broken errors. 1. Idle connections *. Imagine a client connecting to a server and sending a request. If the server takes longer than the read timeout to process the request and send a response, the client's socket will time out during the read operation. The client, perceiving this as a connection problem, might close the connection or try to reconnect. From the server's perspective, the client suddenly disappears, connection broken. 2. Network instability * transient network issues, packet loss, temporary outages, can prevent data from being delivered within the read timeout window. Even if the server is processing the request correctly, if the response is delayed due to network problems, the client will trigger a timeout. 3. Server-side errors * the server might encounter an unhandled exception or a crash after it has partially sent a response to the client but before it has completed. The client then receives a portion of the data, waits for more, and eventually hits the read timeout. This also results in a broken connection on the client side. 4. Firewall/proxy interventions * firewalls or proxy servers sitting between the client and server can enforce their own inactivity timeouts. If a connection is idle for too long from the firewall's perspective, it might terminate the connection, leading to a connection broken error when the client or server tries to communicate. 5. Incorrect timeout settings * setting an overly aggressive, too short, read timeout will exacerbate these problems. Even slight network delays or moderate server processing times can trigger spurious timeouts. Code examples, illustrative. The following examples are language agnostic in concept, using pseudocode to demonstrate the logic. Adapt these to your specific language and networking library, example Python socket, Java's java.net, See system.net.sockets, goes net package. Scenario 1, client-side read timeout. Scenario 2, server-side handling, illustrative. Explanation asterisk. In scenario 1, the client sets a read timeout on its socket. If the server takes longer than read timeout to respond, the client will raise a timeout exception. This signals a potential broken connection, allowing the client to handle the situation gracefully. In scenario 2, the server might detect a connection broken error if the client closes the connection prematurely, example because of its own timeout. The server needs to be prepared to handle such scenarios without crashing. Practical steps to troubleshoot and resolve connection broken issues with timeouts asterisk. 1. Increase the read timeout asterisk. This is often the simplest and most effective solution, if the problem is simply that the server occasionally takes a little longer to respond. Gradually increase the read timeout value until the connection broken errors disappear. However, be careful not to set it too high, as this defeats the purpose of having a timeout in the first place. You need to balance responsiveness with resilience to network hiccups. 2. Implement retry logic asterisk. Wrap your socket operations, connect, send, receive, within a retry loop. If a timeout occurs, attempt to reconnect or resend the request a limited number of times. This can automatically recover from transient network issues. Implement exponential backoff, increasing the delay between retries, to avoid overwhelming the server if the problem persists. 3. Implement heartbeat mechanism asterisk. If your application has long-lived, idle connections, implement a heartbeat mechanism. The client periodically sends a small ping message to the server, and the server responds with a pong. This prevents firewalls or idle connection timeouts from closing the connection prematurely. The heartbeat interval should be shorter than the expected idle timeout of any intermediary devices. 4. Use asynchronous I/O, non-blocking sockets. Traditional blocking socket operations can make it difficult to manage timeouts and multiple connections efficiently. Asynchronous I/O, using techniques like select, epoll, twiu, or asynchronous libraries like asyncio in Python or reactivex in other languages, allows you to handle multiple sockets concurrently without blocking the main thread. This can lead to more robust and responsive applications. With asynchronous I/O, you can monitor the status of each socket and implement more sophisticated timeout handling. 5. Log thoroughly asterisk. Implement comprehensive logging on both the client and server. Log the timestamps of when requests are sent, when responses are received, or timeouts occur, and any error messages. This will help you pinpoint the cause of the connection broken errors and identify patterns. Include the IP addresses and ports of both client and server in the logs. 6. Analyze network traffic, Wireshark, Dump. Use network analysis tools like Wireshark or Dump to capture and inspect the network traffic between the client and server. This can reveal valuable information about packet loss, TCP retransmissions, and connection resets. Examine the TCP sequence numbers and acknowledgements to understand the flow of data. 7. Check firewall and proxy settings asterisk. Verify that any firewalls or proxy servers between the client and server are configured to allow the traffic and are not enforcing overly aggressive idle timeouts. Contact your network administrator for assistance with firewall and proxy configuration. 8. Optimize server performance asterisk. If the server is consistently taking too long to respond, investigate and address any performance bottlenecks. Profile the server code to identify slow areas, optimize database queries, and improve resource allocation. 9. Consider message queues, example RabbitMQ, Kafka. For applications where reliability is paramount, consider using a message queue. The client sends requests to the queue, and the server processes them asynchronously. This to please the client and server, making the system more resilient to network failures and server outages. 10. Handle exceptions properly. Ensure that your code has robust error handling. Catch timeout exception, connection broken error, and other socket-related exceptions. Log the exceptions, attempt to recover gracefully, and avoid crashing the application. Language-specific considerations **** Python, socket, asyncio use socket.setAmout, to set the timeout. Consider using the asyncio library for asynchronous socket programming. **Java, java.net use socket.setSo timeout, to set the read timeout. Use socket.connect, socket address endpoint, in timeout, to set a connection timeout. **C, system.net.sockets use socket.receive timeout and socket.send timeout properties, and socket.connect, IP endpoint, in timeout, to set the timeouts. **Go, net use net.dial timeout, to set the connection timeout and set deadline, /set read deadline, /set write deadline, on the net.con object to set read and write timeouts. Key takeaways **** Connection broken errors when using socket timeouts often indicate a mismatch between client expectations, defined by the timeout, and server behavior, processing time, network latency. **** Choosing appropriate timeout values is crucial. Too short, and you'll get spurious timeouts. Too long, and your application will hang indefinitely in case of a genuine failure. **** Implement robust error handling, retry logic, and potentially a heartbeat mechanism to improve the resilience of your application. **** Use logging and network analysis tools to diagnose the root cause of the problems. **** Consider asynchronous I/O for more efficient handling of multiple connections and timeouts. **** Don't forget to optimize the server-side performance to reduce response times and minimize the likelihood of timeouts. By understanding the interplay between socket timeouts and network conditions, and by implementing the techniques outlined in this tutorial, you can significantly reduce the occurrence of connection broken errors and build more reliable and robust network applications. Remember to adapt the principles and code examples to the specific requirements of your programming language and networking framework. Good luck.